All right, so let's start talking about Chapter 8, which is all about quadratic equations. And so we're going to go all the way through, baby. We're going to talk about how to solve them, how to graph them, and how to use them to solve max-min problems. So let's begin. This first section is talking about a technique called completing the square in order to solve a quadratic equation. Okay, so basically, the first thing we're going to do is talk about this is the first of two videos, by the way. This one is going to talk about the square root property of equality and how to use it. So the square root property of equality is about what you can do as a quick move in order to solve an equation that looks like, well, kind of looks like this or kind of looks like this. So my first question to you is, there are two solutions. I always started this way. There are two solutions to this equation right here, where you take a number and you multiply it with itself to get 9. Can you find them? I bet you got one right off the bat. 3 times 3 is 9. So one of the answers, x is 3. But what's the other one? You sure there's another one, Weber? Sure there is. Usually after a little bit of time, one student or 2 or 5 will go, oh yeah, -3, and there's 5 more that were too shy. So yeah, actually, another answer is -3. There's a little clue with quadratics. You see the 2 there? It's saying, it's whispering to you, hey man, hey buddy, there's 2 answers to this. And so there are. Now, the square root property, what you can do as an expedient way of doing this is the following. X squared equals 9. You want to know what the answer is? Okay, here's what you do. You simply square root both sides. And you got to remember the square root and the square cancel. And we get x equals. Right now we have the square root of just 9, don't we? So when we do this square root property, we got to remember to tack on the old plus minus symbol. So we get plus minus the square root of 9 is 3. It's a fast way of doing things. Okay? That's how it works. So you always try to remember when you square root both sides, there's a plus minus. So let's write that down. When we square root, that is, root, last chapter, we were squaring to get rid of a square root. Nice symmetry here. Here we're square rooting to get rid of a square. But when we do that, when we square root both sides of the equation, I'll put it in red, this red. Don't forget to add the plus minus. Okay, the plus minus is important. Now I kind of cluttered this next example, but can you see it? All right, what happens here? I'm going, now let's find 2 solutions to this equation. Boy, this looks involved. Boy, howdy, but it's not terrible. Let's see. We have a 5x minus 2 squared is equal to 9. So instead of just x squared, it's 5x minus 2 squared. But to remember, what we found is that that thing inside there has to be plus or minus 3. We don't have to think so hard about this. What we can simply do is go, I'm going to square root both sides and tack on my plus minus and cancel the square. And I have a new equation, and it says, I am free. 5x minus 2 is free. On the other side is plus minus 9. Oops, plus minus what? 3. Because we square rooted 9. Okay, so for beginning students that really struggle with this, which is a lot of my students, what happens is I know what to do next. I add the 2 over to the other side, divide by 5. But I think what we should do is be careful and go 5x minus 2 could be 3. 5x minus 2 could be minus 3, and solve them individually. That might be useful or easier. So we're getting 5x is equal to 5, so our first answer is 1. Over here, 5x is equal to what? -1. The other answer is -1/5. And you see, it's not terrible. Just split it into 2 pieces and go to town. So basically, the square root property says this. If u squared equals a, then u is plus minus the square root of a, whatever those numbers are. So I kind of said that up there. Don't forget the plus minus. That's what this little statement's about. Okay? You good? That's how it works. Then I said, I think I have 3 more to do. I want you to do some of them. But so it happens. What happens if the number on the right side is not a perfect square, like 9 or 25 or 49 or whatever? So what? It's the same thing. We just go 9x plus 4. I'm just rewriting is 50. And you're right. I'm going to do the same thing. I have to get rid of the square by square rooting. Now, you don't have to do that, you guys. Let me go back up here. Let me show you this. In this case where we squared both sides, remember this problem? 5x minus 2 squared is 9. We could have FOILed it all out if you thought of that. We could have gone 25x squared minus 10, so minus 20x plus 4 is 9, and go after it and solve it like a quadratic. You can. Bring the 9 over. It actually factors. You got to either factor or you got to do the quadratic formula, and you can solve it that way. But you know what? This was way easier, wasn't it? I mean, just square root both sides. Just remember, don't forget the plus minus. So on this one, I'm going to do the same thing. I'm going to square root cancel, square root plus minus. We get 9x plus 4 is equal to, see, it doesn't square root nicely. Boo-hoo. But really, remember, we're going to reduce it. Why not? So we have 9x plus 4 is equal to plus minus 5 radical 2. You good with that? Are you good with that? Okay. The next steps are to get the 4 over and the 9 over, and you can split it in 2 pieces. You can go, you can split it in 2 pieces. I better do it. So 9x plus 4 is equal to 5 radical 2. The other one is 9x plus 4 is equal to what? Minus 5 radical 2. Now, math people are notoriously lazy. If they see a shortcut, if they get comfortable, they'll use it. And they like to show off to their math friends and stuff. But really, we're going to do the same move each time. We're going to send the 4 to the other side as a minus 4. This is a point of confusion for students because there's radicals involved. But all you really have to do is, I've got 5 radical 2 minus 4. But the world really traditionally just goes, put the minus 4 in front and then plus 5 radical 2. What does it matter? Well, that's what they like to do, so we'll do it. And then you can divide by 9 however you want to. The book will put everything over 9 if you want to. Same story over here. 9x is equal to minus 4 minus 5 radical 2. And then x is minus 4 minus 5 radical 2. What? Over 9. And then you won't see this answer in the book. What you'll see instead is this. They'll put these together, or they'll do it all together at once, and I'll show you that on one of these examples. But you will find the answer looking like minus 4 plus or minus the square root, 5 square root of 2, all over 9. Okay. And that's the book's answer. You know Weber? You know what Weber does? He writes it as minus 4 over 9 plus or minus 5 radical 2 over 9, and that's also good. Or you can just box each one up separately, and I'm happy with that too. Okay, but what I want you to notice is that when you move these guys over, the 4 ends up in front of the term plus or minus, and the 9 goes underneath. Okay, let's try this. You can pause it, try these guys, and then I'll catch up with you. One thing I didn't say to you guys, move this 4 over before you square root both sides. If I square root as is, I've got the plus 4. That's messed up. Okay, so you're going to want to isolate the square thing first. That makes sense? When you do that, it looks like this. We've got 2x minus 5 squared is 12. That's better than the plus 4 hanging out there going, what do I do with that guy when I square root? I can't take care of it. I'm not going to invent anything. This looks like we did just a moment ago. So we're going to square root cancel, square root plus minus. Watch your writing, Weber, it's sloppy. 2x minus 5 is plus or minus. Did you ever see radical 12 in your? Yes, I did too. It's 4 times 3. So 2x minus 5 is plus or minus 2 radical 3. Okay. For those of you that are more daring, what we're going to do is solve this all at once, okay? Instead of splitting it in 2, I'll solve it all at once, and it'll save a little bit of time. Okay, we're going to go plus 5, and I'm going to put the 5 right in front of the plus minus. So now we have 2x is equal to 5 plus or minus 2 radical 3. And that's taking care of these two cases up here all at once. Last step, divide by 2. Weber will go, I'll put it 5 over 2 plus minus 2 radical 3 over 2, which is nice. It actually reduces, doesn't it? So sometimes they have to be reduced, but this is an easy way to do it. I like this answer right there. It's 2.5 plus and minus, plus or minus. It's on either side. All right, one more for us to do, and we'll end this video. So let's see how fast we can go. We've got 5x plus 4 squared is equal to what? Yeah, we're going to move that 20 over. Did you think of that? That's how that works. You can pause this and try it before I get to it. It would be a really good exercise all throughout the semester. In this case, we have a minus 15. So what are we going to do? We're going to square root cancel. And some people go, oh, I can't square root a negative. I'll just kind of put it here. No, 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 no. You got to square root it, whatever it is, regardless of what it is. Minus 15. Oh, really? I got to square root plus minus. So we have 5x plus 4 is equal to, you know what? That looks imaginary, and it is. I'll write it as plus or minus the square root of 15, which I can't do anything with, times I. Yeah, complex numbers too. Bring the 4 over to the other side, pause it. What would you write? What would you write next? Yeah, I'm going to put the minus 4 plus minus square root 15i. And then lastly, I'll divide everybody by 5. So how about minus 4 over 5 plus minus radical 15 over 5 times I. There you go. And I think that's it for this video. Now we'll use this to solving quadratics by completing the square. I'll see you in the next one.